Hi there, my name's Vince from Mr. Telephone, and in this video today I'm going to show you how to change an old master socket to the new master sockets. So at the moment, this is in the UK, you might have a master socket that's similar to this. This is a 2-stroke 1A, or you might have a flush one, which is where you've got the metal back box in the wall. This is a 3-stroke 1A. And I'm going to show you how to change it into one of these. This is an NTE5 with the removable faceplate and the test socket in here. So these have been around for quite a few years now, probably near enough 20 years, but there's still a lot of houses that have the old style one. Now there's nothing wrong with the old ones, they work absolutely fine, but if you want to fit the newer equipment, you won't be able to do that in the old style one. So if you want to fit the VDSL faceplate, or an ADSL faceplate, or an Iplate, then there's no way of fitting these on to the old type ones because they're all designed for the new NTEs. Yeah? Like so. So you need a new NTE5 socket if you're going to be updating your equipment to one of these. So I'm going to show you what you might possibly have in your house, and then I'm going to show you how to wire it up to the new one. So in this instance here, you've got to use your imagination. The black cable is coming in from outside. This is a BT drop wire cable, and then you've got an extension going to another room, for example, your kitchen, your living room, your bedroom, whatever. So imagine this is a long lead going to another part of the house. So we want to take the wires off here and move them onto here. Now in this instance, I'm using drop wire cable, but your master socket might be fed with internal cable. This is 2 pair, so there's 4 wires. You might have 3 pair, there might be some greens sticking out here as well, or you might have 4 pairs, so there might be greens and browns, but the principle's the same. And also you might have this cable here. This is another 2-pair cable. These are the very old colour codes, but also the very recent colour codes, because BT went to this cable again a few years back. So on this instance here, you would normally be using the orange and the blue for the line coming in. On this cable you would normally be using the blue and the white blue, and on the drop wire cable you would normally be using the orange and the white. But your house may be different, so all you need to do is, if your line's working okay at the moment, which it would be because it's been installed for however many years, you need to copy exactly what you've got at the moment. So it might not be exactly the same as in this video, but the principle's the same. Okay, so what you're going to have to do is you're going to have to work out which is your main cable and which is the cable going off to the extensions. Because on this master socket, we want to fit the main wires onto the A and B terminals on the back, and we want to fit the extension wires onto the 2, 3 and 5 on the front plates. So we have to know which is the main cable, because you don't want to connect your extensions here and then your main cable here, because the idea is if you ever have a fault on the line, you remove the front plate and then you're purely testing in the test socket, which is just travelling to this main cable coming in from the street. So if you were to get it the wrong way round, you would find that this is dead and this is live. So you're going to have to work out which are the live cables coming into the house. Now, it may be easy because you might be able to physically trace the black wire coming in from outside, or it may be harder if there's just a huge bundle of wires sticking up, for example in the new build development where you've got the cables all hidden in the wall and they're coming into a metal back box. You might find it hard to work out which one's what. Now if you've got a multimeter, this is easy, because all you've got to do is you've just got to go to your volts DC, not AC, DC, and you're looking for 50 volts across your main wires. So what you can do is your main wires are going to be on the 2 and the 5. But obviously if you've got extensions, you're going to have more than one set of wires in there. So first thing to do is always write down, always make a note of what goes where. So for example, you would say white cable, blue to 2, white blue to 5, orange to 3, white orange to 4. Make a note of that. Take a picture as well. And then you could say black cable, orange to 2, white to 5. Make a note of it. So you know that you can always put it back to how it was in case you muck it up. Now, so what you do is, if you've just got a huge bundle of wires and you can't trace them, get a multimeter and go across the pairs, and then when you go across the wires on the 2 and the 5 that belong to the cables, so for example on this white cable you would go across the blue and the white blue, if you're not registering any voltage, well you know then it's an extension wire. once you go on your main line, the needle or the voltage will jump up to 50 volts, and then you know that's your main line. The other way of doing it is to, like I said before, physically trace it. If it's along the skirting boards, you'll be able to trace the wire where it comes into maybe a junction box by the door, and then you can trace the wire down, give the wire a little tug, make sure it's that one moving, and then you'll have a good idea. Also, often you'll find that if you look at the IDC terminal here, you zoom into that there, you'll often find the bottom wire is the main one, because often when engineers are doing it, they would install the main wires first and then the extension wires on top. So it's probably hard to see, but the bottom wire here is the orange wire, and then the one on top is the blue wire from the extension. So in this instance, you would it's been done correctly, but the engineer might have just thrown it in any old way if they were doing a bit of, if they were out for a fault and then they were just punching the wires back in. So you can't always go by that, but it's still a kind of good idea to, the bottom wire is often the main one, because maybe the main socket might have been installed in the 60s and then, or whenever, the 70s, and it wouldn't be the 60s because these sockets weren't around, but let's say in the 70s, early 80s, if the socket was installed, then a few years later they might have had an extension put in. Well, the engineer's not going to rip out the main wires to put the extension wires in first. They're just going to punch the extension wires in on top. But you will have to work it out. The other way of doing it is, if you haven't got a multimeter, is pull the wires out, and what you can do is you can pull the top wires out and then plug your phone in here, see if you have dial tone. If you've got dial tone, you know the main wires are still connected. If you haven't got dial tone, you know that the wires that you've just pulled out are actually the live wires. So then pull out the remaining wires and push those other wires back in and check for dial tone. If you've got dial tone, then you know 100% which are the main wires. So that's the only awkward bit about this job, is finding out which is the main wires. So in this instance here, as I said before, I know what's what because the black is the main. So I've taken a picture, I've made a note of it. On the extension wires, I have white blue to 5, I have blue to 2, and I have orange to 3, and white orange to 4. And then on the black cable, which are the main wires, I've got white to 5 and orange to 2. So what I'm going to do is I'm going to pull all these wires out now. Okay, so this now is my extension wires, and this one's are my main wires. Now you're going to get your master socket, and first of all we're going to connect up the main wires. So you get your little cable tie, and you put it through that one there. Yeah, that loop there. Okay, and then you cable tie up onto the actual sheath of the cable. So you want to be cable tying the black bit. You don't want to be cable tying the wires, because that can damage the wires over time. So cable tie the actual black sheath and just snip off the excess . Snip off the excess of the cable tie. Now, from before, we know that the white wire went to number 5. Now, on this socket, if you look closely, they're not labelled 2, 3, 4. They're not labelled 1, 2, 3, 4 or 5. They're labelled A and B. So what happens is, A is exactly the same as number 5 on your old master socket, and B is exactly the same as number 2 on your old master socket. So whatever main wire was connected to number 5, you need to connect to letter A on the new master socket, and whatever colour was connected to number 2, you need to connect to B on the new master socket. Now in this instance, like I said, it was white to A and orange to B, but yours might be different. If you're using this cable here, can you see that? You're going to probably be using blue to B and orange to A. But again, you need to double check. If the engineers kind of wired it up a bit wrong in the first place, it will still work, it doesn't matter, because the wire doesn't know what colour it is. So if he's wired it up orange to number 2 on the old master, you'll need to put orange to B on the new master socket. So just copy what you've got at the moment, but you'll probably find it's orange to 5, which is going to be to A, and you'll probably find it's blue to 2, which is going to be going to B here. And again, if you're using this cable, this internal cable, then you'll probably find that white blue was connected to 5, which will be connected to A on the new master, and you'll probably find that blue was connected to 2, which will be B on the new master. So just copy what you've got at the moment. So I'm just going to punch these wires in now. Now when you use your punch down tool, use it nice and straight. You can also get cheap plastic ones that do exactly the same job, but it just means you have to snip the wires. When you use this tool, it cuts. When you punch the wires in, it cuts the excess wires off to save you snipping them. But it's fine because you can just punch the wire in with a plastic tool and just cut off the excess. Now in this socket here, you need to put the wire in that way round, and what will happen is when you punch it in, the tool will be cutting this side here. Okay, so I'm just going to punch that wire in and show you. I don't know whether you can zoom in down on the table there. Got it? Right, so we used a tool, nice and straight. Don't do it at an angle because it can cause problems. Just nice and straight and down like that. And as you go down, the little scissors there just cuts off the excess. But as I say, if you haven't got one of these, it's not a problem because you can just push the wire in using a cheap plastic tool, and then you can just snip the wire excess off. The reason you snip off the excess is if both wires are sticking out and then they touch each other, it can short the line out, and that will cause a problem. Your line will be dead and it will be engaged when people ring it in. So now I'm going to connect orange to B, like so. So that's what you will end up with, like that. Yeah. Now, you might find that on your drop wire cable you've got like a black sleeve over it. That's absolutely fine. Just leave it on there. It's just to protect there's little steel tension wires that run in here. So when it spans over the road, it doesn't sag, and they can be quite sharp. So often you'll find that there's a little black cover that goes over this bit here. So that's absolutely fine. You just use that. And then in this case, the green and the black are just spare wires if you ever had a second line. So there we go. So that's that bit connected up. Now, when you normally buy a master socket, depending on which ones you buy, often they'll come with a back box. So in this instance, because we were going from one of these master sockets, this will be flush to the wall. So again, this is going to be flush in the wall. So there's going to be a metal back box sunk into the wall, and this is going to be flush. But if it's not flush, if you were changing it from one of these master sockets with its back box, well then you would just use one of these back boxes. If the cable was coming through the wall, you would use, they've got loads of knockouts. They've got a knockout here, on top, the sides, the bottom, there's knockouts everywhere. So you knock out the holes that you need. And then if, for example, the back cable was drilled through the wall, you would put it through the hole at the back. So you could put this straight on the wall so it's nice and neat. If it was coming along the skirting board, then you could go up through that hole there, like so. Yeah, so it's up to you how you route the cable, whatever's neatest. Now, again, when the wiring's flush, when it comes to the extension wiring, you can use this little hole here at the bottom, because you can see there's a little cutout here that fits the hole in, or you'll probably find if it's flush that the electricians have put it in, or you might have buried it in the wall before, in which case then it will be coming up from the back box and it will be coming through this bit here. Okay, so in this instance now, I'm going to pretend that that we've got the back box. So that's the back box. I'm just going to screw that back box in. Right, so that's that bit done. Now, Get your phone, plug it in here, you'll find you should have dial tone again. If you haven't got dial tone, it means you haven't gone onto the main wires. So you should now have dial tone in this test socket, here. So now we have to wire up the little extension plate. So you'll probably look at this extension plate and you'll be a bit confused because you will see numbers 2, 3 and 5. And you'll think, where is number 4? Yeah? Now years ago they had 1, 2, 3, 4, 5 and 6, then they went to 2, 3, 4 and 5. Now they've only gone to 2, 3 and 5 because that's all that is actually used. 2 and 5 make the line work and 3 makes the line ring. So 4's not needed. So in this socket here, my extension socket, you can see that 4 has actually been wired up with the white and orange. But that is purely for neatness. Can you see that? Yeah. It doesn't do anything. So if you were to rip that wire out, if I was to take that wire out, it will make no difference at all. It doesn't do anything. It was just connected for neatness. So don't worry if you find that you've got a socket with all 1, 2, 3, 4, 5 and 6 connected. It still makes no difference. You will only be using 2, 3 and 5. 2 and 5 to make it work and 3 to make it ring. Okay, so just punch that wire back in, just for neatness. So now I'm going to be connecting up the other side of this extension here. And again, you've made a note of the wires. So it doesn't matter if it doesn't match this video exactly, or if you've got a different color code again, you're going to be copying what you had previously. So if blue is to 2, blue is still to 2 now. If orange is to 5, if you were doing this one, orange is to 5 again. In this case it will be white, blue to 5. So you're just copying what you had previously, but you're not going to be connecting up terminal 4 or terminals 1 and 6 if you're using maybe a 3 or 4 pair cable, because they're not needed and you've got no room to connect them up. So what we're going to do is, in this instance, I think we're going to pretend that the cable's coming along the skirting board. So we're going to knock out this hole here. Yeah, so that's the knockout there. We're going to pass the cable through up into here. And now we need to wire this up. So again, we get our cable tie. In this one, the cables are going to be coming from this direction. So the cables are going to be going in here. And then we're going to be punching them in. We're going to be punching them in this way, and then we're going to be cutting them this side. So we get our little cable tie, and we put it in this bit here. Make sure you get it the right way around so it can do up. Has to be that way, because if the cable tie goes in the other way, it's not going to zip up. So make sure you put the cable tie in the correct way. Yeah. So you hear it click as you put it in. So you're going to get your wires, pass them through the cable tie, and you want to be connecting them, zipping up the cable tie onto the sheath itself, not onto the wires, onto the sheath of the cable, like so. Yeah. So I'm just going to cut off the excess. Cut off the excess of the cable tie because it gets in the way. Now we're going to bring the wires up here. I'm going to route the wires up here. Now, always leave a little bit of slack. If we were just to connect them up tight here, it makes it hard in the future to re-terminate it again. So always leave a little bit of slack here. So you've got a little bit of room if you have to re-terminate them again if you've made a mistake, or if you've if you have to change this faceplate for whatever reason, if you're fitting an ADSL faceplate or my design of VDSL faceplates, you need to connect up the wires. So you need to have a little bit of slack. Also, if you look closely, you're going to have to get real close for this. Can you see that the wires have all little cut marks in them from when they went into the previous slots on the master sockets? Yeah, can you see there's little grooves? That's where the metal V has cut the plastic to touch the copper on the inside. Well, I think it's always a good idea when re-terminating to re-terminate on fresh wires, not on bits that have already been cut. So what I like to do is don't terminate at the very, very edge like that. push the cable through a little bit so you're terminating on a nice fresh bit of cable, and then you know then it's made a good connection. So in this instance here, it's going to be blue to 2, orange to 3, and white blue to 5, which is up the top, and this white orange wire won't be doing anything. So let me just punch the wires in again, like I said before, nice and straight. And if you zoom in, hopefully you'll see the wires cut. Are you on the orange wire? Yeah, so I'm going to cut now, push down, and as it gets to the bottom you'll see, hopefully you'll see that cut. Now I'm going to do the white blue wire, which is number 5, push down and cut. Again, like before, don't do it at an angle. If you push down at an angle, you're going to spread that metal V and it won't cut onto the copper inside the wire. So always do it nice and straight, and make sure you push down to the very, very bottom of the IDC terminal. So now if you have a look, the wires are all at the very bottom of the IDC terminals, which is where they should be. Okay, and this white orange wire is going to be doing nothing, so just coil it up. It won't be going anywhere, like so. So that's how you connect up the front plate of the master socket. And then what you'll do is, you would then get your 2 little screws, and you'd screw it up, and that's how you convert an old master socket to a new master socket. Then a few weeks down the line, or a few years, a few months, you get a fault on your line, or you're not happy with your broadband speeds, all you've got to do is undo the 2 screws, slide it out, you then get your phone and you plug it into this test point here. You have now disconnected all the wiring in your house, and you're purely testing the black wire which goes out onto the network. Okay, so that's what the test socket is. If everything works fine here, it's not down to your service provider, the fault is down to you. So it's either going to be, more than likely, something faulty that you've plugged into your extension. It could be a fault on the cable, dampness could have got into the socket. It's rare, but you could also get dampness in the front plate as well. That's all down to yourself. So when you plug in if you plug the line in here and it's not working, and you've tried more than one phone because your phone could be dodgy, you know then that the fault is going to be on the network or on this black cable coming in, or it could be down in the exchange or the green street cabinet. But either way, it's a nice easy way of testing whether the fault is on your property or the network. And you can't do that with the old master sockets. You'd physically have to pull out the wiring and then test and punch the wire back in and test. So it's a nice easy way of doing it. And like I said earlier, now you can fit your iPlate, yeah, or you might want to be fitting your VDSL plates, plug it in there, and it allows you to do that. Yeah. So it's handy. Hopefully you found the video useful. If you like it, please subscribe. If you want any master sockets or anything like that, please check out www.mrtelephone.co.uk, and yeah, give it a thumbs up if it's helpful. I appreciate it. Thanks very much. Take care. Bye now.